In the last presentation, we completed the switching circuits for basic gates and or NOT, and also for the universal gates NAND and NOR. In this lecture, we will find out the switching circuits for the exclusive gates. The first exclusive gate is XOR, and we will first look at the truth table for the XOR gate. So let's find out the truth table for XOR gate. A, B are the two switches, Y is the output, and for XOR operation, Y is given as A complement B or B complement A. This can also be represented as A XOR B. This is for XOR representation. We have two variables, so we have four possible combinations. And now we have to find out the output Y by putting the values of A and B in this expression again and again. But I will use one property of XOR gate to avoid this extra calculation. XOR gate is odd ones detector. By odd ones detector, I mean the output Y is going to be high whenever the number of ones in the input bit stream is odd. For example, if I have four variables A, B, C, D, and the value for A is 1, B is 0, C is 1 and D is 1, then we have 3 ones in the input bit stream, and 3 is definitely odd, so the output is going to be high. This is a very simple thing that you can use to obtain the output in case of XOR operation. For the first case, we have A as 0, B as 0. We don't have odd number of ones, so output is going to be 0. For the second case, A is 0, B is 1. It means we have odd number of 1, so output is high. For the third case also we have odd number of 1, so output is high. For the last case, we have two ones, that is even, so output is low. So the output is 0, 1, 1, 0 for the XOR gate. In this way you can obtain the output easily by using this property. Now we will find out the switching circuit for the XOR gate. I will first draw the circuit, then explain you. To implement XOR gate, we will use bidirectional switches. These two switches that we are using are bidirectional switches. This is A, this one is B, this is 0, this is 1. Okay, now we will consider the first case when A is 0, B is 0. A is 0, it means it is connected to 0. B is 0, it means this is connected like this, and in this case there is no current through the bulb, hence bulb is going to be off and output is equal to 0. I will simplify this so that you can see why there is no current through the bulb. So you can clearly see the circuit is not complete, it is opened, and whenever the circuit is open there is no current through the circuit. Now we will consider the second case when A is connected to 0 and B is connected to 1. A is connected to 0 and B is connected to 1, and in this scenario current will flow through bulb. I will again simplify this. And the current will flow like this, and thus the bulb will glow and output will be high. We will consider the third case now, and the third case is just opposite of the second case. A is now connected to 1, whereas B is connected to 0, and again there will be a flow of current like this. You can clearly see the flow of current like this. And for the last case, when both A is connected to 1 and B is connected to 1, we don't have any flow of current through the bulb. So this is how the switching circuit of XOR gate works. Now we will move to the XNOR gate. And for XNOR gate, we have to take the complement of the XOR. It's very simple. A, B are the two variables, the switches that we are using. Y is equal to A complement, B complement, or A, B, and this is represented as A XNOR B. This is the representation for XNOR. Once we are done with XNOR, we will solve this example that will give you an idea how the question is asked in exam from this topic. We have 4 combinations: 0 0 0 1 1 0 1 1, and as this is complement of XOR and we know the outputs in the case of XOR 0 1 1 0, we only have to take the complement of these outputs. So we have 1 0 0 1. So this is how the truth table for XNOR gate looks. And now we are going to make the switching circuit for the XNOR gate. I will draw it quickly. This is logic 1 and this is logic 0. A is our first bidirectional switch and B is our second bidirectional switch. This is the bulb and our output Y and the potential source V. If we compare the two switching circuits, then definitely this one is easier to understand as compared to this one. This is quite straightforward. If I consider the first case, when A is 0, B is 0, it means A is connected to 0 and B is connected to 0, then simply the circuit is complete and bulb will glow. For the second case, when A is 0 and B is 1, A is connected to 0 and B is connected to 1, the circuit is now open and there will be no current through bulb. For the third case, when A is connected to 1 and B is connected to 0, then also circuit is opened. Here you can see it is opened and there will be no current through the bulb. For the last case, when both A and B are connected to 1, the circuit is now complete and there will be a proper flow of current through the bulb and it will glow, making the output equal to 1. So this is how you have to draw the table and then obtain the circuit, the switching circuit for the XNOR gate. And now we will move to the next part of this lecture, that is the example. We have to determine Y. Y is the output and it is the bulb. We are having 1 2 3 4 switches, A, B, C, D, and we will try to solve this problem by two different ways. The first way that I can see is by making this switch A closed. This A should be closed. B or C, either one of them should be closed. So we can write A and B or C, and D must be opened, because when this is closed, the current will have two paths. If this is the current I, and when D is closed, this current I can have two paths. The first one is through the switch and the second one is through the bulb. And definitely if you talk about the resistance, then the resistance of bulb is greater as compared to the resistance of the switch. So current will select the least resistance path. So current will go like this and there will be no current through the bulb. So D must be opened in order to make the bulb glow. So we will take and D complement because it should be opened. A must be closed. Out of B and C, one must be closed and D must be opened. So this is what we got if we do the analysis directly. This is the fastest way to find out the output Y. There is one other way also. Let's see how to find out the output in that case. We have to find out all the different ways to glow this bulb. The first way is to make this switch A closed. So I have A, and to make this switch B closed and B, and to make this switch D opened. So D complement. This is the first way, and we have option. Whenever there is option, we use the OR operator, and when there is compulsion, we use the AND operator. All these three conditions were compulsion, so we used AND operator here. In this case also you can see all these three conditions must satisfy to glow this bulb, so we have used AND gate. But now we have option, so we are going to use OR gate, and the option is, let's make this A closed, and we are not going to make B closed, but we will close switch C. So we have C, and I will make D opened. So these are the two ways to glow this bulb, and I can write this as A and B or C and D complement, which is same as the first solution that we obtained. So this is how you have to approach for the problem. You can do whatever you like. You can divide circuit in 3 parts like this, and you can analyze each part individually and obtain this result. Or you can think of different ways. We have 2 ways. This is the first one and this is the second one to make the output high. I will suggest you the first method because it is easy and possibility of mistakes are high in the second method. This is all for this presentation. See you in the next one.